If you want to create your first deep learning application for classifying the contents of an image and you don't know where to start, in this quick tips episode, you will learn how. Keep watching! Hi there! I'm Manuel Gutierrez from thelighthouse.co, and I make videos that help you learn about different programming topics like AM, Docker, TensorFlow, Unity, and more. So if you're new here, hit the subscribe and the bell notification buttons below so you don't miss a thing. Let's start! This video is part of the ASL classification series where you'll implement a simple deep learning model using TensorFlow and Keras for classifying images. First, we define the problem that we want to solve, identifying hand signs for the American Sign Language ASL, this video. Then, we collect or download some data representing examples of what we want to learn how to classify. Images of hands representing the ASL fingerspelling signs. We define and train a model that can capture, learn, and classify the visual data. We evaluate the performance of the model to see how well it is classifying images. Finally, we use the trained model for predicting hand signs. Don't forget to join the free mini course in the description below. In this, the first video for the Deep Learning ASL classification series, I will talk about what ASL and in particular what fingerspelling is. I will create a Jupyter notebook in VSCode and add some initial libraries that I am going to use in the series. In this video, let's talk about the problem that we want to solve. We want to be able to identify ASL fingerspelling signs from images. And let's quickly talk about some important aspects of it that will help us when selecting the dataset and defining the model. A signed language is a formal natural language that instead of using sounds for communication like English or Spanish does, it uses hand gestures, facial expressions, and body postures for that purpose. Sign languages, like spoken ones, also come in different flavors like American Sign Language, ASL, British Sign Language, BSL, Colombian Sign Language, LSC, and so on. Like with a spoken language, where we can take words apart by spelling each letter using the alphabet, for sign languages we have what is called fingerspelling, which is the manual representation of the letters and numbers by using the hands, for example. Given that most fingerspelling signs are static, meaning that from just one image, we can identify if someone is making the sign for an A, a Q, or the number 0, we are going to implement a simple model to help us identify or classify these fingerspelling signs. We are also going to ignore the letters J and Z, given that they require movement, meaning a set of images or a video in order to be identified or classified. For this series, you will need to have Python installed. You can do that by installing Anaconda. I am going to create a Jupyter notebook inside VSCode. Make sure that you also have the extensions for Python and Anaconda. On the command palette, type Jupyter and click on Create New Blank Jupyter Notebook. Save it and name it ASL classification.ipymb. Set the first cell as a markdown cell and double-click on it. Add the #1 set up the notebook title into it. You can create markdown cells to document the purpose of each section. Add a new cell, which will be the code cell where the modules or libraries that I'm going to use are going to be included, like OpenCV for loading and modifying the images, Glove and OS for iterating through the files on the dataset folder, matplotlib for plotting the results for the model and also for showing the loaded images, and scikit-learn for splitting the dataset and also for one-hot encoding, tensorflow and keras for the classification model. If you are missing any package dependencies required for the series, you can just type conda install and add Jupyter, OpenCV, matplotlib, tensorflow.js for GPU support, or if you don't have a compatible GPU, then just TensorFlow, and finally scikit-learn. You can run the cell by clicking on the green play button or by pressing Ctrl-Enter or Command-Enter on the Mac. I am also defining some global parameters in another cell, like the number of images to process at the same time and how many iterations to perform while training, the width, height, and if it's a color image. In the next video, I'll start by talking about some possible datasets already available for our use on the internet, how to load the images with the fingerspelling signs, and how to prepare the images for training the model in a future video. Awesome! Congratulations and thanks for watching! You can join the free mini course associated with this video by clicking on the link in the description below. Share any comments or suggestions about the series or future topics. And if you like the video, also hit the like button below.